Hi lovely people, today we're sketching curves. This video will take you through how to sketch curves with a particular focus on turning points. The examples I'll do are 1 and 6. So if you want to have a go at them beforehand and follow along with the video, that would be cool. Okay, let's get started. Y equals 3y equals x to the cubed plus 3x squared. Our job is to draw a picture of that and label the turning points. Okay, so my first thing I'm going to do is differentiate it to find where the slope of the curve equals 0. To do that, I go 3 times 1, the first number that's out the front of the pronumeral. So 3 times 1 is 3, x, and then I take 1 away from the number in the index position, which is 2. That's 3x squared. Then I add 2 times 3, so 6, x, and the 2 goes down to 1, and we don't bother writing the 1. So I've just got 6x. So that's my dy dx, or the derivative of y. When I want to find out when it's when it's a stationary point or a turning point, I look for a 0 gradient. So I set that equal to 0, and I go 0 equals 3x squared plus 6x. Then I solve it by factorizing, because I want to think of two things that will times together to give me my 0. Okay, so one of those is going to be 3x, because it's the biggest factor in both. Then x plus 2. Okay, so from that, I know that one of my factors is 0, because when x is 0, 3 lots of 0 still make it all 0. And the other is minus 2. Okay, so to make these points and not just x values, I need to sub them into my original equation. So when y equals 0 to the power of 3 plus 3 lots of 0 to the power of 2, my y value is 0, the point 0, 0. When y equals minus 2 cubed plus 3 lots of minus 2 squared, that gives me minus 8 plus 12, which is 4. So the point is 2, 4. Okay. Now I also want to find out if they are maximums, minimums, or point of inflection. To do that, I'll look at what the derivative is doing around those points. So I put them into a table. X, and then dy dx underneath. Now the value I'm picking, first of all, is 0 from my x value, and that goes there. Then minus 1, because it's to the left of 0, and plus 1, because it's to the right of 0. So 0 has a 0 gradient. Minus 1, when I substitute it into my derivative, gives me minus 1 squared times 3, which is 3, plus minus 6, which is a minus. Overall, that's a minus answer, so I know my gradient is negative coming into the point. It's 0 at the point, and 1 substituted into the derivative gives me 3 plus 6, which is a positive answer, positive coming out. So I know from this picture of minus 0 plus that it's a max. Sorry, that's a minimum value. It's at the bottom of the curve. I do the same thing for 2, minus 2, and 4. So minus 2 goes in the middle because it's my x value. I pick minus 3 because it's to the left, and minus 1 because it's to the right. And I already know that that's 0, and that minus 1 is a minus from the previous table. So I just put 3 in. Sorry, minus 3 in. And I get minus 3 squared, which is 9, times 3, which is 18, plus minus 12. Sorry, minus 27. Sorry, all my mental calculation skills died there. Start again. 3 squared is positive 9 times 3, which is 27, plus 6 times minus 3, which is 18. That's still a positive answer. Okay, so this one goes up, stays, and then goes back down. So this is a maximum. Okay, so now I draw the graph. Okay, I label my x and y axis. Then I put my points in, which are 0, 0, and minus 2, 4. I know that this is a minimum, so it goes in and up. This second point's a maximum, so it goes up then down. Okay, and just for neatness, I want to find out where it crosses that line. I've already got an x and a y intercept at 0, 0, and labeling the other would be nice. So if I factorize the original equation, I get x squared outside of x plus 3. And that gives me a 0 at negative 3. So I know that this one is negative 3. And that's a complete sketch of the curve. Okay, that's the procedure. That's all the steps. I know there's a lot of them. If you go through them step by step and focus on what they're doing for you and what each step is telling you, you should learn and remember them pretty quickly.